Good morning to one and all present here. I am Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I am going to share a small article regarding unsupervised learning. So what do you mean by unsupervised learning? Unsupervised learning is basically a learning without a teacher. So the data set which we are given as an input to the AI model does not have any labeled data set. So it has an unstructured model. So it finally it is used to identify some patterns or structures from the data set which we have provided as an input to our AI model. So in such kinds of things we will apply the unsupervised learning. So what do you mean by clustering? Clustering techniques are unsupervised in the sense that the data scientist does not determine in advance the labels to apply to the clusters. So clusters are the group of similar items. So the structure of the data describes the objects of interest and determines how best to group the objects. Clustering is a method often used for exploratory analysis of the data. In clustering, there are no predictions made. Rather, clustering methods find the similarities between objects according to the object attributes and group the similar objects into clusters. Clustering techniques are utilized in marketing, economics, and various branches of science. There are primarily two categories of clustering: hierarchical clustering and partitioning clustering. Hierarchical clustering is further subdivided into agglomerative clustering and divisive clustering. Partitioning clustering is further subdivided into k-means clustering and fuzzy c-means clustering. K-means clustering. Given a collection of objects each with n measurable attributes and chosen value k of the number of clusters, the algorithm identifies the k clusters of objects based on the object's proximity to the centers of the k groups. The algorithm is iterative with the centers adjusted to the mean of each cluster's n-dimensional vector of attributes. K-means is a centroid-based algorithm or a distance-based algorithm where we calculate the distances to assign a point to a cluster. In K-means, each cluster is associated with a centroid. The main objective of the K-means algorithm is to minimize the sum of distances between the points on their respective cluster centroid. Next is the K-means algorithm. Here we choose the value k, that is the number of clusters and the initial guesses for the centroids. Compute the distance from each data point to each centroid and assign each point to the closest centroid. Compute the centroid of each newly defined cluster from step 2. And we have to repeat the steps 2 and 3 until the algorithm converges. Stopping criteria for K-means clustering. There are essentially 3 stopping criteria that can be adopted to stop the K-means algorithm. Centroids of newly formed clusters do not change. Points remain in the same cluster. Maximum number of iterations are reached. Next is the distance measure. Distance measure determines the similarity between two elements and influences the shape of clusters. K-means clustering supports various kinds of distance measures such as Euclidean distance measure, Manhattan distance measure, A-square Euclidean distance measure, and cosine distance measure. Determining the number of clusters, the value of k can be chosen based on a reasonable guess or some predefined requirement. However, even then it would be good to know how much better or worse having k clusters versus k minus 1 or k plus 1 clusters would be in explaining the structure of the data. Next, a heuristic using the within sum of squares metric is examined to determine a reasonably optimal value of k. In other words, WSS is the sum of the squares of the distances between each data point and the closest centroid. The term indicates the closest centroid that is associated with the ith point. If the points are relatively close to their respective centroids, the WSS is relatively small. Next is the applications of K-means. Some specific applications of K-means algorithm are image processing, medical and customer segmentation, and also the unsupervised learning is widely used in many areas. And here the The main objective of the clusters is, here we have divided the clusters based on the guess or some predefined requirement. So by whenever we are trying to divide like this, so we have to examine to determine the reasonably optimal value of k. So like in the sum of the squares of the distances between each data point and the closest centroid. So here also the closest centroid that is associated with the ith point also refers to be very close to the respective centroids, and then the WSS is relatively small in such cases.